So let's start off with forward proxy, right? So basically, SSL decryption comes in two forms, right? There are basically two forms, which is one is forward proxy, the other is um, the inbound. Right? So in SSL decryption, right? As per technology, there are two things, right? One is the forward proxy, right? Forward proxy, and the other one is inbound, right? So in forward, what you mean is, right? We always talk from the perspective of firewall. Assume that you are the firewall in sense,
Client, hello.
right? It's the client hello, right? SSL client hello,
Yeah.
right? So it has an important parameter which we discussed. What is that? From a firewall perspective, very important. What is that? What is
So
that parameter? Not
cipher
cipher
suit.
suite. Yeah, cipher suits are important, but from a URL filtering perspective, we talked about it.
SNI.
Correct. SNI, server name indication, right? Which
Yeah.
is nothing but what? In this case, it will be www.gmail.com,
Yeah.
right? So the URL that you're trying to connect, the web server's name, right? That is what the SNI is. So this is helping us in the URL filtering part and all, right? That means
Yes.
you are allowing or blocking Gmail, right? That decision is made on this, right? SNI is very important. Similarly, in decryption also, some traffic we might not want to inspect due to many reasons, right? Due to decryption problems, due to compliance issues, right? Other complications that are needed. We might decide not to decrypt certain traffic. So we need to tell which URL traffic which you don't want to decrypt. So this SNI is very important in that, right? The decision whether to decrypt or not is based on the SNI or the URL categories. Or you can basically go for all, which you never can do actually. Right? There will always be exceptions, right? So a client hello is coming. So what happens here is the firewall will evaluate, right? Identify that this is an SSL application and it is towards gmail.com, and it will see if there is a decryption policy match. So to enable decryption, you need a decryption policy. A policy is needed. So decryption policy match has to be there for this URL or the category, right? And we are saying, okay, decrypt all, right? Gmail or Google traffic. We have a policy. So what it does is it's going to send the client hello there. You can modify this. It can go to as it is received, or it will be basically modified. Basically, it will be modifying it, right? That means in the decryption policy, there is something known as a decryption profile where you can alter some things, right? That means the ciphers, the encryption algorithm that you use in ciphers, the hashing algorithm that you use in ciphers, it can be controlled. The SSL TLS version that you use, let's say client is sending TLS 1.0, we don't want to use that, right? We want to restrict only to TLS 1.0. That is possible. So you can tell your firewall to make modifications on behalf of the client so that, right, the firewall can modify payload data in this request, right? So if you're sending with SSL version 1.0, right, the firewall can actually modify and send a new request towards the server where it contains TLS 1.2, right? So those kinds of possibilities are there, right? So basically, right, for simplicity's sake, let's say, right, there is no complication there, right? We are sending the request directly. So there is a client hello, but definitely there will be changes, right, in the working as such. Why? Because the cipher, the client random CR function and all will be different, right? Client random that the client sends might be 1234. Here it might be different, right? 164, right, let's say. It's different. So you can make changes, but ideally, right, not so significant, right? This is not where the actual magic happens. It's the next message is from the server, right, to back. What will be that? What is that message in SSL?
Server hello along with the certificate.
Right. The server hello payload and a server certificate. So asking you this, Gmail server, right? Gmail server is sending you a server hello, a server certificate. That certificate will be signed by whom? What do you think? The certificate that Gmail is presenting, who will be the root CA who signed it?
Any certificate authority.
Who would be that? Give a random example.
Like might be anything like third party, some DigiCert or
Right. It might be any well-known CA, right? Any third-party
yeah,
CA that you know about. It can be Verizon, it can be DigiCert, it can be GoDaddy, right? Any
yes.
well-known CA. But in case of Google, Google is its own CA. Google has a CA also, so they sign it with Google CA only. Okay. For if you take
Yeah,
Facebook for example, it uses DigiCert, right, to sign their certificate. So basically, all public web servers will use a public CA, right? Their certificate will be issued by a public CA,
yeah.
right? So the certificate is coming. So what key does the certificate contain?
It's public key.
Only the public key, right? Only the public key is sent to us, right? This
Yeah,
is the public key of the server certificate is there, right? And the signature is also, digital signature is also there in the certificate, right? The CA digital
yes,
signature is also there. Cool. So we get this. So what the firewall does is, right? Firewall will read the certificate, right? So let's say this is the certificate that Google is sending. So it will have common name equals gmail.com, right? Then SAN value, right? Star dot google.com, right? Then expiry would be there, right? Valid from valid to date, right? That is start date and end date basically, or expiry. Then
yeah.
other OCSP parameters, right? Then there will be CRL distribution points. There will be the digital signature, the signature algorithm. A lot of values are there, right? So these are all the attributes in the certificate. So what your
Yes,
firewall does is it will read the certificate that the server presented. It will copy all of these values. It will understand all of this. And what it will do is it will create a new certificate. The firewall will generate a new certificate, which will be signed by root CA. This root CA that we have on the firewall, right? We will be creating the company's own root CA certificate on the firewall. This
it's
certificate with the
self-signed, right?
public, yeah, it's a self-signed certificate, right? It's
Yeah,
signed by itself. It's a
yep,
certificate authority which is signed by itself, right?
yes.
And the public and the private key, right, of the certificate is available on the firewall,
Okay, got it.
right? So what the firewall does is it will read the server certificate and it will identify what is the values that is there in the attributes, and it will generate a new certificate which is signed by root CF. So basically, it will be a duplicate of this. The only difference will be that, right, the CA, the actual certificate was signed by Google CA, but here this will be signed by the internal root CA,
Yeah,
right? And
it's
this is
altogether certificate.
right. It is known as the on-the-fly certificate, right?
Oh,
So it's generated on the fly. That is right. It's more like a technical term, right? Not customer facing, but more like a technical term on the fly. That means you cannot see this on the firewall GUI and all. For every transaction you accessing Google, there is an on-the-fly certificate created. You access Facebook, there is a new on-the-fly certificate created for Facebook. So every SSL site you access, there is a new certificate generated. It's all in the firewall memory, all right?
yeah,
So this is a certificate, a new certificate, right? Mimicking the actual server certificate is generated with the same parameters. The values will be same. CN is equal to gmail.com. SAN is equal to star.google.com, right? Expiry, CN value, everything, right? OCSP here, all of this, right? It can have, right? Now, what it does is it's signed by root CA. We generated the certificate. The firewall is generating. Since the firewall is generating this, the firewall has what? The public and private key of the certificate, right? This is a
yes,
new certificate generated by the firewall, right? It's like you copying somebody else's certificate and creating a dummy of that, right? But it is instead of Google CA signing it, it's my own root CA, right? So the public and the private key of this new server certificate is available on the firewall. So what it does is now the firewall will send the server hello and the server certificate, right, to the client. But the certificate will be the on-the-fly cert,
yeah,
right? On-the-fly cert with the public key alone, right? This public key alone will be there in the certificate and it will be sent to the client. So this will be signed by the CA will be what? Root CA, internal root CA.
Yes.
So why did we do this? What is the logic there? Why did we create a dummy certificate and send it signed by root CA?
Question. Yeah.
Even I have this question.
Right? This is the important part, right? If you
Yeah,
understand
this
that,
is the correct. This also answers why need that root CA the clients.
why what was the difficulty? What is the problem if we send the actual server certificate to client? And what is the benefit we get by sending a dummy certificate that we created? What is the difference there in two cases? If we send the Google's own certificate to the client, and if we send our own certificate to the client, what is the difference there? What is the benefit? What is the additional thing that the firewall is having?
Like, I'm just guessing the answer. Like, I'm not sure. I think if like this firewall will validate this Google certificate, and if there is any error, it will directly drop the traffic there instead of sending to the client.
Okay, but that is you're talking from after decryption perspective, security perspective. Yes, as you said, right? From Google, some malicious traffic is coming, we'll block it. The client will never get the packet. Agreed. But I'm asking from
Like
a
if you don't,
decryption perspective. What is the benefit that you're getting? Right? What is the difficulty, right? If you send the Google certificate to the client, and what is the benefit that you get when you send a custom on-the-fly cert instead of actual Google certificate?
okay, we can't read that encrypted text directly without this root certificate. Like this here, the root certificate is decrypting the traffic.
Root is the root. So is the root certificate decrypting it? Does Gmail have, or let's say, does Facebook have DigiCert CS certificates for private key and all? No, right? No, DigiCert is not going to give the CS keys to anybody else.
Yeah.
Okay. Okay. Right. We'll hold on. No worries. Right. I mean, when you go to the next step, you'll understand why. So
Okay.
instead of the server certificate, now we are sending a new on-the-fly certificate with the same parameters. Only difference is that the CA is now different, right? It's root CA. Now, what happens here is when the client gets this, right? It is a client behavior, right? As part of SSL handshake, the client has to validate this, right? That means the client has to actually check, right? For what do you call the so when the client gets the certificate, right? When a certificate is presented to a client by a server, what does it do is it will check what is the CA there, right? So what it is going to do is it's going to check its trusted root certificate store, right? To verify if this root CA is present there or not. First thing, right? That means the issuer of the certificate should be present in the trusted root certificate authority store, right? We should have this certificate, right, in our store, right? So this is a mandatory requirement. If you don't have this, what will happen? What do you think will happen? If you don't insert the root CA to the client certificate store, what will happen when the client gets the certificate?
Like we can't read that certificate and like.
Okay, so as an end user, what will you see on the browser?
And yes, and
Will the web page load or not? First thing. In the initial go, will the website open up or not?
it will not load.
Okay, agreed. A website will not open up. What would
Yeah.
be the error that you would see?
Something like this. Check the network connection from proxies.
No, it will be unknown CA or untrusted CA, untrusted root certificate, right? Typically, depending on browser, it can change, but typically it is unknown CA or untrusted root certificate. The client
Okay.
is complaining that the CA is not trusted by the client. You're presenting a certificate signed by some root CA. I don't trust this guy.
Yeah.
Right. So but you always have the advanced option to proceed, but an end user will get alarmed at that stage, right? Certificate error should not be visible at all. So this root CA is a mandatory thing. You should have this on the store, client store. So what happens is, right, you know about the digital signature. When the client is getting this certificate, right, it will check the root CA store, ensure that it is the present. What it does is the certificate will have something known as what? The digital signature, right? So the digital signature is nothing but a certificate, right? The hashed certificate, right? Which is signed by the CA private key. So what they will do is they will just use the root CA, right? In your certificate store, the root CA is present with its public key. Using this public key, the certificate hash, the digital signature, right, can be verified, right? You use the public key and you get the hash. And what the client will do is client will calculate the hash for the certificate, the actual server certificate, and compare it with the hash that is there in the digital signature. If both matches, that means it is signed by the same root CA and it is trusted, right? So it is trusted if it is present in the store, and it is verified by verifying the digital signature, right? By taking the certificate hash there, right? So this is one important thing, right? Root CA should be present on the client, right? Else it will throw an error, untrusted or unknown CA. Now what happens is, once this is verified, right, there are also other parameters that it checks. CN or the SAN value should match with what you entered on the URL bar, right? You typed facebook.com, but you're getting a certificate with CN with google.com. It will throw an error, CN mismatch error, right? All of that is there, right? That means what is the URL you're trying to access, right? The request URL should match with either with CN or SAN, right? It should match. If not, it will throw an error also. Okay. So ideally everything will match. We tried accessing Gmail, right? CN is gmail.com. It is matching root trusted, signed by root CA, which is present. The digital signature verification also is successful. So now what the client does is it will generate something known as the pre-master key, right? Client calculates the pre-master key, and what does it do?
It shares that pre-master key along with the.
It's encrypted, right? Pre-master key is encrypted using what? It's encrypted using what? The server's public key. The public key, right? This public key that the server is having, right? Encrypted using the server's public key, right? So pre-master key is the symmetric key here, right? The public key of the server is the asymmetric key pair here. So the pre-master key, I'll call it PMK1, right? The pre-master key 1 that the client generates is encrypted using the public key of the server, which is this key that we generated, right? This new certificate was generated. The firewall has this public and private key pair. Only the public key was sent to the client. The client generates a pre-master key and it is encrypting using the right public key and sending it to the firewall, right? So it's a client key exchange, right? Client key exchange. Now the firewall, when it gets it, what it does is, right? Since it has the private key, right? The private key is there with the firewall. It can decrypt and obtain what? The pre-master key.
Yeah.
The logic why we use the certificate is to get this private key. If you had sent Google certificate to the client will encrypt using the Google's public key. We cannot get this pre-master key without having Google's private key, which Google will never share it to us. Right? We are generating this new certificate so that it is a new certificate with new asymmetric key pair, and we are sending the public key to the client so that the client is generating the pre-master key and encrypting using the public key that we have given, so that we can decrypt using our private key, which we have. So we are creating a new set of keys and the certificate just to ensure that the private key is with us so that we can get the pre-master key. To obtain the pre-master key, you need to have the private key, right, of the server, which you cannot get if you're sending the direct certificate of the server, right? Google or Facebook is never going to share their private key, right? The whole point of the SSL encryption is lost there. So we are mimicking a new certificate so that we get a new key pair, and we are sending the public key. So we are getting the pre-master key by decrypting it with the private key of that on-the-fly cert. Right now we have got the pre-master key. Similarly, the firewall will send, right, the client key exchange payload, right, to the server, right. It will use a different pre-master key, right, as such, right. Let's say PMK2, right, and basically it will be encrypted using what? The public key of what? Google.
The roots.
Right, Google's public key, right? Google has sent the public key here, right? So basically, assume that,
Yeah,
right,
got it.
there are
Yes.
two legs, right? Two-legged, right? That means between the client and the firewall, there is a SSL connection, right? And
Yeah,
between
got
the
it.
firewall and the server, there is a different connection. So two-leg connection. That is what it's called, man in the middle, right? There is a transaction happening. You go in the middle and you become the broker there, right? You take the request from the client. For the client, you are the server. For the actual server, Google server, you are the client, right?
Yes.
Right? Firewall is acting as a server in this side and client on this side,
Yeah.
right? So it's going to encrypt the pre-master key tool with the public key of Google's own certificate, right? And Google will get the pre-master key, right? Using what? Their private key. Using their private key, they'll decrypt it and they'll get this. So now everybody has the pre-master keys, and then they will calculate what? The session keys. So there will be a session key 1 here, session key 1 on the firewall. Since we are using separate key, session key 2 here, session key 2 here, right? The pre-master key. Based on this key, session key 2 is created. Based on the PMK1, a session key 1, right, is created.
Yeah.
So basically, the firewall has this keys, right, to decrypt, right, both of the sessions, right? And what happens next is once the session keys are there, right, the client can send the payload. What is that payload known as? The application data payload is what? The encrypted HTTP get that you sent. Right? I'm just skipping the other part, right? I mean, if it's a TLS, ECDHE base cipher and all, there is other messages. Server key exchange, server parameter, right? That means there is a Diffie-Hellman key exchange and all. When your cipher that you're using in TLS is more complex, elliptic curve Diffie-Hellman exchange, if it uses, it's basically PFS function. To add more complexity, they are adding more exchanges. Right? We're not going into that. But here, right, after this, the client is sending an HTTP GET, which is encrypted using session key 1. So the firewall gets this. It is going to decrypt it using session key 1. It's going to do L7 processing, right? It does the app ID, CTD, all of threat analysis, everything. Then everything is good. It's going to encrypt using session key 2 and send it to the server. The server will read it with session key 2. Then the reply will come. It will be encrypted with session key 2. Firewall will write, decrypt using the session key 2, inspect, do the L7 inspection, then re-encrypt with the session key 1 and send it back to the client. So session key 1 here, session key 2 here. Two sets of keys there. The firewall is working. The stage that is working here is the proxy stage. Right?
Got it.
So why did we use the root CA? Now summarizing. Why did we use the root CA there? What was the purpose there?
Like to read this pre-master key, we need the private key and all.
Correct. To get hold of the pre-master key from the client,
Pre-master key.
we need to have the private key of the server.
Private key. Exactly.
So Google is never going to give us their private key, right? Or any web server is not going to give their private key. So what we did is we had to create a new certificate, right? That mimics the same actual server certificate. But to create a certificate, we need a CA certificate, right? A CA is required to sign something, right? So we have this root CA created so that we can create new certificates
private and public key.
Right, new certificate key pair, right, for different transactions. So this is this is happening on the fly. That means you accessing in a given second, there are 10,000s of sessions going through. So the firewall is generating 10,000, 20,000 certificate in a given point. It's all on the fly. In memory, it is happening in the proxy stage, right? Depending on your firewall model, concurrently 7,000, 10,000, 25,000, right? 1 lakh sessions are getting decrypted. So that many sessions mean that many certificates are being generated on the fly, right? So it's very right from a firewall perspective. It's right too much memory intensive. You need an SSL hardware, right, to accelerate it as well. Right? For example, Fortinet and all, they use hardware acceleration for this, right? There is a separate chip which is dedicated for this SSL inspection and all, right, which gives them much more throughput for this, right, processing.
Yeah, adding to that point, I mean, almost all vendors use this MITM techniques for forward proxy. So to quickly check your traffic is being inspected by someone, when you browse a website, you click on the certificate and you would see something a different root CA. So whatever we see the root CA, right, where the firewall is in the firewall we created root CA, it will have some name. So you would see I visited Google, and the issuer is something like PanW. It's not Google. Google's issuer. So you would see, okay, there is a man in the middle, which
Yeah,
generate another certificate. Yeah. So that's how we understand there is a MITM, and
correct.
so yeah,
Yeah,
yeah.
I have done this. Like we'll see the certificate of like which we created in the firewall. We'll see that name in the client.
Yes, yes. That's why we need that root C on the client and the trusted store. Else we will get warnings, all those
Yeah,
security. Yeah.
got it.
So that's yeah.
So, but yeah, this is
Yeah,
a important understanding, guys. You take any vendor, this is the technology in the heart. There is no MITM is what SSL decryption is all about. You take any proxy, right? I mean, in proxy, there is a slight modification that, right? It's a proxy architecture. Everything is getting going as a request, proxy request to the proxy. But at the end of the day, SSL transactions are decrypted the same way. They have their own CA, which will be trusted by the client. They'll be generating new certificate on the fly. Same technology, any vendor you take, right? Cisco, Fortinet, Checkpoint, Zscaler, whatever it is. Everything is same, right? Same working only, right? So this is what we are going to do in our lab, right? We will decrypt it, right? So on the prerequisite part, we have to create a self-signed root CA. We have to load it on the firewall, right? We can create it externally, or we can create it on the firewall itself, right? And then, right, we can basically, we should also ensure that it is loaded to the known. A lot of new things are happening in that. That's a little more, right, complex. But yeah, from decryption troubleshooting, right, this is what typically you do. But if you're working with TLS 1.3 and all, right, then this logic might not work. Why? Because your packet capture, all the payload that you see here, right, these might get encrypted. You can't see any of these details. Certificate even you can't see, right? When you
Yeah,
do with
maybe
yeah.
we can do another capture TLS 1.3.
No, in TLS 1.3, I mean, we can actually show a TLS 1.3 PCAP, right?
Yeah, that's easy. So you would see certificate encrypted. So we won't get any information from packet capture. But at least
Right.
you can client hello will be visible. The packet length, all those parameter exchange, all
I,
you can keep it handy. Yeah.
so here server name is there, but typically
Yes.
SNI encryption is also there. There is a new thing in
Yeah.
TLS, right? SNI encrypted SNI option is also there, where you can't see this also.
Yeah.
Now, let's see, right? I mean, this is yeah. So this is what I'm talking about, right? So it's all encrypted, right? Everything is encrypted. Every record is encrypted. You can't see what is the data, right? All of the payloads are there, but you can't see it, right? In the server hello, right? You can't see. So in this scenario, what you need to do is, right, you can't actually rely on a PCAP to actually troubleshoot this. You need to take what is known as a packet diagnostics, right? Where the firewall, you can start with a global counter actually. You can check the global counter and see what is the counter that is getting incremented when you see this transaction is failing. But sometimes global counter might give generic output counters, which might not be so right conclusive. In that case, you go for diagnostic, where you go for SSL basic and proxy basic, if I'm not wrong.
Shall we show them those commands? Those are the ones. So you need to set that filter properly. We set a filter, right? So you do debug data plane packet diag show settings, I think, right? Will show the current settings applied. And then we enable features one by one, or maybe together. Then, debug it on. And we would see a lot of, gibberish, maybe, because we don't understand that log. But, that logs tells a lot for them, maybe the developers. Yeah, but it will show, right? I mean, in the logs, it may show if it's an error info level. All the logs will be visible on the packet diag, I guess.
Hey, Sachin, just give me 2 minutes, right?
Yeah, sure. So also, you can decrypt the traffic of the client side itself. When you see a TLS 1.3, it's very difficult, right, to capture the packets on the Palo Alto and see what's really going on. So you can definitely do a packet capture, and you can decrypt all those sessions on the client itself. You can use tools in the Wireshark tools. You can use. I will share. I think 1.3 can be decrypted from the client itself. There is one called Fiddler Capture, and also in Wireshark we can decrypt it. But for that, there should be, I think private keys, or there should be some parameter we have to input. Let me check that video.
Yeah, it's the SSL session key, right? If you're doing it from the
Session key, yeah.
firewall, right? Typically, what you do is there is an internal KB as well. On the firewall, if you're trying to do a capture and you want to decrypt it, you have to take a diagnostic and get the session key from the firewall, and then you need to load it into the Wireshark preferences, where it will show the decryption. That's one way,
Yeah.
right? That's how we decrypt and see. Right, that's possible. And Fiddler is very good, right? Very useful if you want to decrypt and see. Fiddler is the thing, right? You can install it. It's another man in the middle, right? You install it, it will install a CA. Everything is channeled through Fiddler, right? It listens, so it adds a proxy configuration on your browsers to Fiddler. So your browser will send packets through Fiddler. Fiddler will decrypt and see, and then only it will send it to the actual server. So, all right, you can use that as well to see. But yeah, too much work if you go for Fiddler and all. I was too lazy to do that. But yeah, I mean, global counter is very useful if you have a problem, and the diagnostic part, right? And SSL diagnostic, packet diagnostic for one particular URL for one user and all, right? Very, very less impact, right? If you do it correctly, there is no problem, right? So how do you do that, right? Debug, data plane, packet diag, set log, feature, and you go for SSL basic, right? So you enable SSL basic, and then you set proxy, right? Proxy basic, right? You set these two features. So, right, once you see that log, log, what was it? Packet tag to setting, yeah, this one, right? You can see here, right? Features that are set as, right, proxy basic and SSL basic, right? Once this feature is enabled, I'll set the filters on the UI, right? In the GUI, I'll be setting the packet filters like this, right? From the client IP to that server to that IP, about all of this, right? I'll enable it, right? Packet capturing is not needed, right? Just the filtering is enabled and the filters are set. Then, right, on the these stages are set. And what I do is I'll go for debug data plane, packet tag, set log on, right? And packet diagnostic is now enabled, right? And now the client can actually use right, access the page. Right, when they access it, right, the traffic is going through and it's getting counted, right? Once the decryption error has come, then you will stop it on, off. Once you've done that, you aggregate the logs, right? Packet diagnostic aggregate logs. And now the log is ready. It's called pan packet tag, right? So I think MPFN log and store packet underscore tag dot log. This is the log file, right? So if I type for SS Corp, I should get it. Yeah, that connection. Third subject, CSS Corp, server name, right? Everything is. If there is a decryption problem, this file will have your solution, right? You have to just patiently. You can export the tech support file and get this, or use the session output of the CLI also, right? It's your wish how you want to typically, right? Go for the CLI output if it is very easy, right? Or you can go for the tech support file, which will have this file, pan packet tag, right? And then you have to patiently read through it and find the error. And you will get tons of tickets with the same error. Right? Decryption things are very relatable. You will always find matches. Right? It's very easy to find matches. Right? This is how you do it. Typically, right, for you guys, you might need approval, right, to do it, right? So always get it verified from your technical lead, right, if you're doing it. Nitin, you can also do it. There is no harm in doing it. But the thing is, right, it's diagnostic is a risky thing. The only thing is, right, if you're not too confident, don't do it, right? Let the support guys do it. And if something happens, you can always blame them. Right? So,
yeah. Also, you can do it. I mean, you can run shows, running resource monitor and see
Right.
how is your DP usage. If you're testing it, if there is no user, not active traffic, you can just properly set the filter, narrow it down, so that we only log those packets. So, keeping the filter is the key. So you
Right.
will get, so you only log that traffic. That means processor need to only track those packets.
This
So
filter,
yeah.
right? Sorry to cut you off. This filter, right, is wide open actually from any client, right? So in actual networks, what you should do is you should pick the actual client's private IP to right, and then go for it, right? So this is how you should ideally go for it, right? Be as specific as you can. Don't keep anything as a wildcard there, right? Always be specific and use. So the very specific this filter, the more easier the path, right? Else it will start. If other traffic matches with your filters, the logging will be exponential and will cause DP to go high, right? And typically, right, support should already know that, right? You guys should already know that, right? Typically, this output is needed for you guys, right? Before you run it, and right, so running resource monitor output is needed. Make sure, right, you're not going under 85, right? Sorry, above 90, 85 is okay, I would say, but yeah, typically, right, depends on people to people. 85 to 90, and now, thing if you think the resource utilization is going, right, don't do it, right? Better to do it during a non-business hours, right, after hours and all, right, or take a maintenance window and do it. Right, there is a huge high chance that, right, you can think. But yeah, if it is well below 80 and all, go ahead, no problem. Make sure that your filters are airtight and right, do it. Right, or for Nathan as well, you can do it, right? Not main thing, but main thing from a customer perspective, what I feel is sometimes, right, when you have the data also, you might not be able to understand it, right? So in support, typically what they do is, right, they might see a keyword error, this is the keyword, but they don't know it. What they'll do is they'll copy and search in their internal, right, Salesforce database, where they can see similar tickets, where they will read through the tickets and understand what that error means. Whereas an end user, it's very difficult for you to actually get it, right? So if I search this keyword in the internet, I will not get any output. Why? Because this is internal to Palo Alto. Right. So that is one thing, but it will significantly help if you give this data and open a ticket. You just give this, right? Typically, I used to work in EMEA region where we would see tickets coming in where they would come with diagnostic output itself. They'll say, this was the problem, this is the PCAP, this is the diagnostic. Don't call me, don't message me, just give me a solution. That's it. Right. So in that case, you can cut short unnecessary troubleshooting, right? What I felt right, working there is a lot of time end users are very busy, right? It's not one ticket that they have. They might have 50 tickets managing other tons of solutions, right? Every day, one troubleshooting call, too many hours, right? That the time is critical for them, which they can't afford. So what they will do is, instead of wasting time, they will do it on their own time and then they'll share it, right? End of story. You come up with answers, right, based on this data, right? And right, sometimes customers also give this feedback. Level 1, level 2 support is not adequate, right? They take more time, they wasted our time. These kinds of feedback, they to avoid that, they do these things, right? So when you open tickets like this, that case actually, right, there is no back and forth discussion happening, right? Did you do this? Did you that? No, nothing. No more probing and all is needed. Every data is provided to them. They can come with a solution or they can directly escalate if they don't know it, right? So your fast case can be fast forwarded when you have the state and all.
Yeah.
But yeah, filters should be good.
Yeah, adding to that point, so some company may have, L1, L2, L3 level of, access, or, they will have certain roles. So let's say if an L1 engineer knows better how to debug this, you can send a report, like, let's say, this is what I'm thinking, like with the logs, all, if you send it, right, you will get, attraction. I mean, people will notify you based on the work. So if you know more about this, if likewise, if you see an issue, SSL decryption broken, you can note down all this. Did a packet capture? This is the client hello. This is the server hello. These are the length I see, and this debug. And if you see some error, you just point that out. Just call that out. I saw an error. I don't know further, but it looks like an error for me. Likewise, you can highlight these things. So that's a good advantage. Many people doesn't know this, so it is truly an advantage. Yeah.
Right, absolutely right. I mean, this is how you show value, right? So these things, when you show, right, they that means that typically these things are now at this point, right? New folks cannot know this, right? Because this is not any more public facing right now. Right? They've removed it as a public facing KB to an internal KB. So when you're able to get this data and show them, hey, this is what I see, right? I'm not sure this is what the error means, right? It can be different, right? We can double check with the support, right? When you show that, right, that shows that you're going into very depth to actually find out the root cause and all, right? And you're able to. So typical Wireshark analysis and all, if you do, right, what I have seen is at least most of the US and Indian Asian customer base, they don't go into that effort where they do a capture, the analysis. No, they open a ticket, then the support guy comes in, captures it, he has to do the RCA, all of that, right?
Yeah.
Right, but you could save time and show value to your leadership as well, right? When you actually come up with, hey, this is what I did, right? This is the capture, this is the output, this is what my assumptions are. Correct me if I'm wrong, right? That's it, right? That shows a quality, and your cases will be coming to a closure very faster, right?
Yeah.
That shows value, and right, that shows effectiveness, and you can show off internally within your team as such, right? It's not about show off, actually. It's showing technical capability, more like.
Exactly. Even I have seen cases like 2 month stretch. I mean, it's an intermittent issue. Customer is not available, tag is not available.
Right.
It's like it
Right.
will extend. So if you pitch in there and do this effort, that will be really great in terms of visibility, in terms of your eagerness to learn all things. Yeah.
See, at least I'll tell you, right? In my example, I have seen a lot of, when I came to my current company, right? I got a ticket for their account that is more than 390 days old. 390 days. Assume that that's more than 1 year. The case has been running, right? And it's running, and there is a lot of data that is yet to be collected after 1 year of trouble. I don't know, understand what they were doing, right? So the customer is not free, or when the customer is free, support guy is on leave. Support guy, when he's there, customer has gone to vacation. These things are right happening, and it's a bloodbath there. So these kind of things avoid, right? That is what you see in EMEA actually, right? In Europe region, customers, when they open, right, because of language barrier and all of that, right, they don't want to interact with support too much. They give all the data in email. That's it, right? And they ask you to. You can just tell them what you want, and they will get it. That is what they need. So that they want to fast track the process. So do that, right? This is very helpful. The pan packet diagnostic part and all, if you're able to do. Only thing is, be very specific with filters. Don't play with the filters with an open filter. Keep 000 and all. Don't do, right? Specific IP, source IP, specific destination, and the return port protocol. Right? If you mention that, this is a good filter, right? Interface also, if you're able to specify, well and good, right? But at least 1, 2, 3, 4. This is mandate. There, any questions?
Yeah, I think there is an auto off function kind of thing. I don't know.
Yeah,
That is
400 MB for packet capture. There is.
Oh, okay.
Right.
Okay.
It will hit 200 MB first, and then it will start to create a new file. And next 200 MB, it will start delete. It will delete the old one and replace this. So maximum 400 MB of VCAP per stage it will capture.
Oh, okay.
And that depends on the firewall model also. I think in lower end, it might be a little more shorter because of the internal disk crunch. Right. But 400 MB is what I've seen. Right. Yeah. So that's the thing. And one more thing, guys, right? I mean, just to show you this, right? I mean, let's get some pace here. So I'm just going to this website. Right? This is a good website for testing. So I'm actually I'm trying to access a certificate which uses an untrusted root. Right? If I see the issuer for this website, untrusted root bad SSL, is bad SSL untrust root certificate authority. I'm getting an error here, right? My browser is saying that certificate authority is invalid. It is not trusting it. Right? The server is presenting an untrusted issuer signed certificate. Hence, my browser is throwing this error. Right? As an end user, this is what I expect when I access some malicious site and all, which is not having a trusted issuer. But let's do the same thing on the scenario that we have, right? Our internal client goes to bad SSL, right? He tries to access the untrusted root. The page loaded and it is showing secured, right? If you see the certificate, it is using the pan lab. This is the problem. So when the server is presenting a certificate which is signed by an unknown CA, we have to ensure that the client is also getting that error. Client should get a warning that this is presenting an unknown certificate, right? This is unexpected, right? I mean, if I access some phishing URL which is using some on self-signed certificates and all, as a client, I will never identify that. Why? Because it's always signed by the root CA, that pan lab root CA, and it will be trusted, right? So typically what happens is whenever you connect to a server, when the server is presenting a certificate, firewall uses the certificate store. So when Google is, or let's say Facebook is presenting a certificate signed by DigiCert, firewall checks if the CA that signed Facebook certificate is present in the store or not. Right? It checks the CA, the issuer as well. So if the server is presenting an untrusted issuer, right now we don't have a method to inform the client. Right? It will be using the same certificate to sign the on-the-fly cert. We want to decrypt. At the end of the day, we want to decrypt. Right? But we do not have a mechanism to tell the client. For that, you need to have a new CA. Right? We call it as forward untrust CA. Right? I'll call it untrust CA. Right? So this is a CA certificate that is there on the firewall. It is self-signed and it is signed. It's a certificate authority. But this will never be loaded to the client. This should never be loaded, right? It should only be available on the firewall. The client should not know about the CA. And I have to mark it as forward untrust certificate, right? Forward untrust. So what the firewall does is, when a client accesses a website and the website is presenting a certificate which is not signed by a trusted issuer, that means when a website is presenting a certificate which is signed by CA, which is not present in this list, that means it is using some untrusted CA signed certificate. Then what the firewall does it, it will create the on-the-fly cert and present it to the client. But instead of using the trusted root CA, it will use the untrust CA or the forward untrust certificate. So when the server presents an untrusted issuer signed certificate, the firewall will use the untrusted CA certificate to sign the on-the-fly cert, so that the client will get the CA warning, untrusted issuer warning. So the same site, right? I'm going to block it. I'm going to open it again. I'll go for an incognito to avoid caching. Incognito, it will go to untrusted root. I see showing certificate authority invalid. If I see the certificate, it is signed by untrust CA, forward untrust CA. Right? So did you get the point why we need an untrust CA? Whenever the server is presenting an untrusted issuer signed certificate, right? When any server is presenting a certificate which is not signed by a well-known CA, the firewall, what it does is it will create an on-the-fly cert, but that will be signed by untrust CA, not the forward trust CA, and use the forward untrust CA. Since this CA certificate is not loaded to the client, it will throw an untrusted certificate authority error, so that the client is intimated that the website you're trying to access is presenting an untrusted issuer certificate, right? He can't see what the actual certificate was. Why? Because we are doing man in the middle, but he is getting that error. And then it's his discretion to go ahead or not. Make sense? Any questions here, guys?
No, bro.